Hello and welcome to this second part of this tutorial. And the goal of this part is to get to the point where we will be able to create these planes onto which the cross-section sketches are going to be later. And to do that, we have a bunch of construction geometry to do first. So we will have to create these cycles and then these lines which will be tangent each one to at least 2 cycles, and from that we will get the position of cross-section planes and we will later be able to create the planes. Okay, so let's get back to Inventor and we will have to create another sketch. But before getting to that, as you can see, I have all these dimensions displayed. The way to hide these dimensions is to select the sketch and then right click and deselect dimension visibility, and as you can see the graphic area is much cleaner. Okay, so now let's create our second sketch. So we will select the sketch tool again and then select the XY plane, and we will right away launch the cycle tool. And again we will start with this, and what we should do is to use as center point this end point, and as you can see we cannot select it. So we will escape the cycle tool, and what we need to do first is to use this project geometry tool so we can include one of these endpoints to the new sketch. So we will select project geometry and select this one, then this one, this one, this one, this one, and so on and so forth. This one, this one, this one, and this, and this. If we need more, we will do that later. So right now we have all these points included, and now we can go back to the cycle tool and we will use this point, this first point, and now we have to define the diameter. As you can see in the print we have only the radius, so we will type this value and multiply it by 2. So 337 multiplied by 2. So we have the first cycle created, then the second we should have 327 multiplied by 2 again, and then for the third one should be 316 multiplied by 2, then this should be 304 multiplied by 2, then 293 by 2, next 281 by 2, 268 by 2, enter, and 256 by 2. For this one 242.5 by 2, then this one should be 228 by 2, enter, this one 215 by 2, and this should be 202 by 2, and for the 3 last we should have the same value, which is 192 by 2. So this one like this and this like this, and what I will do is to use this equal constraint. So select this one equal to this one equal to this one, and now we have our cycles in place. So now what we can do is to hide this center line. So you just select this, deselect visibility, and what we are going to do next is to create lines which are tangent to the cycles. So this will be a little bit tricky. We have to be careful so we don't mess up. So we'll have to just create something like this, like that, like that, like that, like that. And what we want to do is to avoid these constraints. Maybe I should take some time to check how to override this unfair constraint. I thought that the Alt key should do the trick, but it is not working as I thought. Maybe there is another key, I don't know, I'm not sure, but I will check that later. So for now, what we'll do is just to go ahead like this, and we will come back if there is something to fix, or delete constraint we do not need. Okay, so like that. So the first thing I will delete is this parallel constraint, this one, this perpendicular again, this perpendicular, we don't want that again, this one, that's it. Okay, so now we are going to add tangent constraints. So select the line, the cycle, the line, the second cycle, this line, this cycle, and this line, this cycle, this line, this cycle, the same line, the second cycle. I didn't pick the line. So the line, the cycle, the line again, the cycle, the line, the cycle, the line again, the cycle, the line, the cycle, the line again, the next cycle, and so on and so forth. This one and this one, this one to this one, this one to that one, this one to this one, and this one to this one. Oh, okay. Now we are going to stop that, grab the endpoint and move it so it is close to the final location, and maybe it will behave a little bit better. So like this and like that. Okay, let's go on. So this to this, this to that, this to this to that, that to tack, tick to tack, tack to tick, tick to tack, and something is not going as it should. So this one, I have a tangent to this one, I need a tangent to this one. So let's try that again, and not working. Why? I don't know why, but this time it should be okay. And that's it. This one and this to this, not working. Escape, grab this endpoint, move it closer to the final location, this one too, and this to that. Maybe I already added. Okay, yes. So tangent this to this, and this one to this. You see, we have only one tangency for this line. We will add a second one later. Okay, now that we have this, we will define where it is possible the location of the cross-section sketches plane. So we'll use the line tool again, and we'll start from this one to the intersection point between these two. The next one will be from this point to this one, again this to this, 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 this to this one, and again another one there, to here, this to that, this to that. Now escape to finish the line tool. We will delete this last line because we do not actually need it. This last one will represent the sheet metal component which meet the deflector. So to define it further, we need to build the deflector geometry first. For that, we will need to borrow this line and this one also from the center line sketch we did previously. So we will have to make this sketch visible. So we'll toggle on the visibility, and next we will use the project geometry tool, and we'll project this line, this one, and this one. Now we can escape to finish the project geometry tool, then toggle off the visibility of this center line again, and we will create first this horizontal line. So we will use our line tool again from this endpoint and horizontal line. Now line tool again, we are going to draw the deflector geometry. So we make sure that we have enough space, and we will start with an horizontal line, then another line, a third line like this. Now we need the arc at the end. So to do that without leaving the line tool, what you have to do is to go back to the endpoint of the last line, then drag, and as you can see you have an arc created. Then release the left mouse button and move all the way up to this endpoint. Okay, now the radius of this arc should be, as you can see, 12.5 millimeters. So dimension will have 12.5, and escape to finish. We are going to drag the endpoint of this, if I can get to it, or maybe this one. Okay, now make sure that these two lines are parallel, which is okay now. That this line and this arc are tangent. As you can see, we have a tangent C. That this one and this one are tangent again, and pretty much it. Next, we need the center of the arc to be coincident with the intersection of these two construction lines, and we need the arc to be tangent to this 765 cycle. So now we will add a cycle, and we make sure that the diameter is 765 millimeters. And next we will add a tangent constraint between this arc and this one, and a coincident constraint between this and this. And as you can see, we have an error message. So Inventor cannot create the constraint because it will over constrain the sketch. And this is happening because there is some inconsistency between the dimensions in the print. And to illustrate what I mean, we are going to switch to this Inspect tab, and we are going to activate the distance tool. We know that the radius of this arc is 12.5 millimeters. So in order to be able to constrain this endpoint to this one, the distance between this point and this cycle should be also 12.5. So I will select this endpoint first, then the cycle, and as you can see, the distance is 12.485 millimeters. So this is why we cannot constrain this center point to this endpoint. Okay, so now we have to make a decision. And what I decided to do is to constrain instead this center point to this line. As you can see now, we have a slight gap between the 2 points, and we are going to have to live with that. Next, we will define the length of this edge, and as you can see on the print, this is almost the thickness of the sheet metal component, so we will guess that it's somewhere around 12 millimeters. So we will use the same value, 12, and we will grab this line and drag this endpoint somewhere like this, and we will add a constant constraint between this and this. And we know that the length of this line should be the interior radius of this cylindrical sheet metal component, so 700 divided by 2. So we will use 350 as the dimension, so 350. And to finish the deflector geometry, we will make this line perpendicular to this one, so we will add a perpendicular constraint between this to this. And as you can see, the two are not touching. The perpendicular constraint is not a good idea, so I will remove it. And what I will do instead is just to add a coincidence constraint between the line. And now we have the deflector fully defined. We will not constrain this endpoint to this one, and you will see why later. So for now, to define the work plane at this location, we will just add a line from this center point to this one, and this will actually be a temporary position for this work plane, and you will see why later again. This side is now complete, so what we have to do next is to move on and define the work plate location on this side of the casing. To do so, we are going to show the centerline sketch again, and we will add this line to the second sketch. Escape to finish, then hide this again, and we will start with a line, so just a basic horizontal line. We will make sure that the center point of the line is coincident to this, and we'll add another line from this endpoint to somewhere like this, an horizontal line of course, and we'll add an equal constraint, so this one between this line and this line. This first line will define the first work plane for this sheet metal component, and this one will define the position of the second one. Okay, so we will need this third one to define this intermediary component. Okay, so for the length of this, it will basically be the same as for this one. So what we need to do is to add a vertical constraint, and we will select this endpoint and this other one. Now the overall length of this line is 700, and it is controlled by this dimension. And maybe what I should do is to remove this and instead add this dimension as a diameter. So okay, next we need a line from this endpoint to this one, and we will remove this vertical constraint first, and we will make sure that this line is tangent to this one. And to create the final work plane position, we will use the intersection point between these two construction lines, and we will end up at the intersection point. Okay, Now a last one, which should be this one. So line tool again from this point to this one. Okay, now we can proceed and create all the work plans. So we will finish the sketch and we will take some time to rename it WP, then underscore locations. Okay, now to create the work planes, we are going to use this plane tool group. As you can see, there is a bunch of options available. I am not going to go through what each of these options do, but I will instead link to a good tutorial. You will find the link in the description, and I will only use this general plane option. So this option will allow us to define our selection as we go to get to the result we want. So to create our planes, we need two inputs, and since all the planes will be perpendicular to the XY plane, we will select the XY plane first, and then we will use the work plane location lines as inch lines to complete the definition of the plane. Okay, so we need to expand this origin folder, then select the XY plane, and the first inch line we will use will be this one. And as you can see, we have a plane which is perpendicular to the XY plane, and here we have to define an angle to complete the definition of the plane. We are going to keep 90 degrees, and we are also going to keep an eye on this arrow. This arrow defines the normal direction of the plane, so we are going to make sure that for the remaining planes the direction is consistent to this first one, so that the planes are always oriented in the same way. This will be really important for the next part of the tutorial, when we will be creating the cross-section curve later. Okay, so I will accept this 90 degrees angle, and now we have our first plane created. One thing we will want to do next is to resize the plane. To do so, we select it and move to one of these dots at the end until we see the double arrow, then drag and move it down. We will do the same for this. If I can, okay, select it first, then okay, I can just drag it. So we zoom fit first, try with this corner, drag and resize. As you can see, it's a little bit time consuming. I wish there was a clean way, a better way to do that. So first one is done. Next we will create the second plane. Again, we use the general plane tool option, select the XY plane and the inch line. We make sure that the normal direction on this side, then accept. Now we will resize the plane, so something like this, then move it to the position. Next one, we use the XY plane, then this will be the inch line. Okay, I think I made a mistake, so I'll just delete. Okay, which one? This one. I will right click and delete it. Delete. Consume sketch and feature, no. Okay. Okay, so let's go back to it. Plane, we select this one and then the inch line, accept, select it, resize it like so, then drag it. Okay, escape, then drag it onto position. Maybe I should resize it a little bit more, like so. Then bring it back into position. Okay, I'm going to follow the same procedure and create the remaining work planes, and then I will come back for part 3 to show you how to create the cross-section curves. Okay, as you can see here, the orientation is not the same as it was for the other one, so I will change the angle from 90 degrees to 270 and accept. For this one again, okay, as you can see, everything is in place. Now I have to resize them. This is a complementary video, and I want to expand further on how to resize a plane in Inventor. So what I show in the video is I was selecting the planes and then looking for the corner where I will have this double-sided arrow, and from there I will resize the plane, then move it again to the position where I wanted it. What I found later is that when you have this move glyph near the cursor, if you want to have the double arrow instead, what you have to do is to click once, as you can see. Then I can now resize the plane. So how does it improve the workflow? Well, the first thing I did later is I move one side to the correct location. So from this to this should be the half of the length of the plane I want. So now I will grab this end corner and resize it to somewhere like this, and now I have the plane position and at the size I want. Okay, this will conclude this part of the tutorial. All the work planes are created. So next part we will create the cross section curves. Hope to see you then, and thanks for watching.